Hi everyone, welcome to the Comptia Network Plus course. How to optimize performance. You know that bandwidth is to networking as water is to life, and you're one of the lucky few if your network actually has an excess of it. Cursed is the downtrodden administrator who can't seem to find enough of it, and more fall into category than the former. At times your very sanity may hinge upon ensuring that your users have enough available bandwidth to get their jobs done on your network, and even if you've got a 1 gigabit connection, it doesn't mean all your users have that much bandwidth at their fingertips. What it usually means is that they get a piece of it, and that they share the rest with other users and network processes, because it's your job to make sure as much of that 1 gig as possible is there to use when needed. I'm going to discuss some really cool ways to make that happen for you. Quality of service refers to the way the resources are controlled so that the quality of service is maintained. It's basically the ability to provide a different priority to one or more types of traffic over other levels for different applications, data flows or users, so that they can be guaranteed a certain performance level. QoS methods focus on one of the 5 problems that can affect data as it traverses network cable: delay. Data can run into congested lines or take a less than ideal route to the destination, and delays like these can make some applications such as VoIP fail. This is the best reason to implement QoS when real-time applications are in use in the network to prioritize delay-sensitive traffic. Dropped packets. Some routers will drop packets if they receive them while their buffers are full. If the receiving application is waiting for the packets but doesn't get them, it will usually request that the packets be retransmitted, another common cause of a service's delay. Error. Packets can be corrupted in transit and arrive at the destination in an unacceptable format, again requiring retransmission and resulting in delays. Jitter. Not every packet takes the same route to the destination, so some will be more delayed than others if they travel through a slower or busier network connection. The variation in packet delay is called jitter, and this can have a nastily negative impact on programs that communicate in real time. Out of order delivery. This is a result of packets taking different paths through the network to their destinations. The applications at the receiving end needs to put them back together in the right order for the message to be completed. So if there are significant delays or the packets are reassembled out of order, users will probably notice degradation of an application's quality. QoS can ensure that applications with a required bit rate receive the necessary bandwidth to work properly. Clearly, on networks with excess bandwidth, this is not a factor, but the more limited your bandwidth is, the more important a concept like this becomes. DSCP. One of the methods that can be used for classifying and managing network traffic and providing quality of service QoS on modern IP networks is differentiated services code point, DSCP or diffserv. Diffserv uses a 6-bit differentiated services code point, DSCP, in the 8-bit differentiated services field, DS field, in the IP header for packet classification. This allows for the creation of traffic classes that can be used to assign priorities into various traffic classes. In theory, a network could have up to 64 different traffic classes using different DSCPs. but most networks use the following traffic classifications: default, which is typically best effort traffic; expedited forwarding, which is dedicated to low pass, low latency traffic; assured forwarding AF, which gives assurance of delivery under prescribed conditions; class selector, which maintains backward compatibility with the IP precedence field, a field formerly used by the type of service or TOS function. Class of service, the second method of providing traffic classification and thus the ability to treat the classes differently, is a 3-bit field called the priority code point PCP with an Ethernet frame header when VLAN tagged frames as defined by IEEE 802.1q are used. This method is defined in the IEEE 802.1p standard. It describes 8 different classes of service as expressed through the 3-bit PCP field in an IEEE 802.1q header added to the frame. The classes are shown in table 20.2. Unified communications. Increasingly, workers and the organizations for which work they are relying on new methods of communication and working together. Unified communications UC is the integration of real-time communication services such as instant messaging with non-real-time communication services such as unified messaging, integrated voicemail, email, SMS and fax. UC allows an individual to send a message on one medium and receive the same communication on another medium. UC systems are made of several components that make sending a message on one medium and receiving the same communication on another medium possible. The following may be part of a UC system. UC servers. The UC server is the heart of the system. It provides call, control, mobility services and administrative functions. It may be a stand-alone device or in some cases a module that is added to a router. UC devices. UC devices are the endpoints that may participate in unified communications. This includes computers, laptops, tablets and smartphones. UC gateways. UC gateways are used to tie together geographically dispersed locations that may want to make use of UC facilities. They are used to connect the IP-based network with the public switched telephone network PSTN. Traffic shaping. Traffic shaping or packet shaping is another form of bandwidth optimization. It works by delaying packets that meet a certain criteria to guarantee usable bandwidth for other applications. Traffic shaping is basically traffic triage. You're really just delaying attention to some traffic or so other traffic gets A-listed through. Traffic shaping uses bandwidth throttling to ensure that certain data streams don't send too much data in a specified period of time, as well as rate limiting to control the rate at which traffic is sent. Most often traffic shaping is applied to devices at the edge of the network to control the traffic entering the network, but it can also be deployed on devices within an internal network. The devices that control it have what's called a traffic contract that determines which packets are allowed onto the network and when. You can think of this kind of like the stoplights on a busy freeway or ramps where only so much traffic is allowed onto the road at one time based on predefined rules. Even so, some traffic like carpools and emergency vehicles is allowed on the road immediately. Delayed packets are stored in the managing devices first in, first out buffer until they're allowed to proceed per the conditions in the contract. If you're the first car at the light, this could happen immediately. If not, you'll get to go after waiting briefly until the traffic in front of you is released. Load balancing. Load balancing refers to a technique used to spread the work out to multiple computers, network links or other devices. Using load balancing, you can provide an active passive server cluster in which only one server is active and handling requests. For example, your favorite internet site might actually consist of 20 servers that all appear to be the same exact site because the site owner wants to ensure that its users always experience quick access. You can accomplish this on a network by installing multiple redundant links to ensure that network traffic is spread across several paths and to maximize the bandwidth on each link. Think of this as like having two or more different freeways that will both get you to and to your destination equally well. If one is really busy, just take the other one. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.